privilege to introduce our speaker for the day, Mr. Prashant Akeja. Mr. Prashant works as Senior Software Engineer at SAP's BTP AI unit. He has more than 8 years of experience in industry with a special focus on artificial intelligence, cloud, event-driven architecture, and software-defined storage. Prior to joining SAP, Prashant worked as software engineer in Dell Technologies. Prashant's educational credentials include an MBA degree from Indian School of Business, ISB, and bachelor's degree in engineering from SRM University. Prashant sir, I welcome you for today's session.
Thank you so much, Karthik. It's wonderful to be here with all of you today and talk about evidently AI. So I'm looking forward to making this session very interactive, right? We have sufficient time, so I do not want to get into a monologue. I hope that the audience can just be participative in this session as well, and we can take it forward as a dialogue. All right.
So before can I request all our participants to switch on their cameras so that we could have a nice interacting session?
Yeah, that would be wonderful.
Over to you, sir.
Yeah, perfect. So I will share my screen. All right. So Karthik and others, are you able to see my screen? Can somebody quickly confirm?
Yes, sir. We can see your screen. We can see your screen, sir. Yes.
Topic that I'm going to talk about today is evidently AI, ensuring transparency and accountability. So before we start, as I've already mentioned, I request you to keep your video on because we want to make this as interactive as possible. I also request you to please participate actively in this discussion because I do not intend to make this into a monologue. Rather, I want everybody to take this session forward together as a unit rather than me speaking alone. I also, excuse me, request and encourage everybody to ask questions. All right. I do not know where you are, where you stand in your artificial intelligence or responsible AI or machine learning journey. Whatever the question is, please do not hesitate and feel free to ask any questions that come to your mind. All right. Having said that, let us actually begin this session with a question, right? So this is an open-ended question for the audience, right? What comes to your mind when you think of responsible AI? So I'm looking for some volunteers to please unmute themselves and answer this question. Would anybody like to give it a try? Anybody from the audience? No one? Am I able to hear, or is it on mute, or nobody wants to volunteer? Okay.
You are audible.
Okay. Perfect. So you can even fine. That's okay. If nobody wants to volunteer, that is fine. So I will tell what comes to my mind when we think of responsible AI. I do not want my AI systems to really go out of hand. Okay, I want my AI systems like Chat GPT and all the large language models that exist out there to behave in a consistent and predictable manner, so that if anybody I know, right, or anybody in my circle, uh, a child or an elderly person uses those AI systems, then I expect those systems to ensure that the responses that are produced do not harm the safety of the individuals consuming the AI system. All right. So uh, let us begin. Before we actually dive deep into evidently, right, which is a framework. Uh, I believe that any technology that exists out there exists to solve a particular problem. Okay. Uh, Technology without a problem perhaps makes no sense. So, first we discuss what is the problem at hand, and then we will discuss how evidently AI actually solves it. Okay. So, we will speak in the context of responsible and reliable AI. All right. So, with this, let me introduce you to trust and reliability in AI. The large scale adoption of artificial intelligence system requires trust. If we want to make artificial intelligence a part of our everyday life, then we must be able to trust AI. Otherwise, the large scale adoption would be very difficult. The second point is that the response produced by AI should be free of bias. So no matter whether a person of color or a person from a particular geography or a person of a particular gender or a caste asks a question to AI, the answer that is produced must be free of any bias. And AI should not hallucinate. When I say that it should not hallucinate, it should not give me an answer thinking that it is so and so or XYZ person, because that is what hallucination is. And finally, like I mentioned, a few minutes back, AI should not go out of hand. We have seen recent examples where uh, there were cases reported by large organizations like OpenAI of very dangerous experiments coming out of AI labs, such as the artificial intelligence getting to a point of general intelligence and teaching itself, learning to program on its own, and artificial intelligence systems communicating between themselves in language that was incomprehensible by humans. So that are examples where AI was tending to go out of hand, and that is what we need to monitor, and that is what we need to proactively stop. So why is responsible AI such a hot topic these days? Why is everybody talking about responsible AI, trust, and accountability in the field of artificial intelligence? Okay, so I want to give you a few examples which actually elucidate this point. So, in a recent study, Gardner warned that Gen AI will directly lead to the death of a customer by 2027, right? So most of you would have heard about Gartner, that it is a very reputed ratings organization, and most of the large organizations in the world want to get themselves on the top of their list when it comes to Gartner. And an organization like Gartner says that by 2027, we will see the first death, which would be a direct consequence of generative AI. This shows how important it is for us to take transparency and accountability in the field of artificial intelligence, and how important it is to produce safe and reliable artificial intelligence systems. There are many other examples that I want to share with you today. So, one such example of data leading to bias is right before you in front of your screen. So, as you know, that artificial intelligence has also been used to actually profile a lot of people who have gone behind the bars. So in this case, what happened is that there was an artificial intelligence system which was trained to determine whether or not a person who has been behind the bars is low risk or high risk. So as you can see on the screen, there are four individuals, right? And amongst these four individuals, Vernon and James have been classified as low risk, whereas Brisha and Robert Cannon have been classified as high risk. And one of the reasons that this classification was trained was biased data. According to that data, now I am not a racist person, but the data on which that particular artificial intelligence system was trained, it classified people of color, with more likelihood of committing offenses again and again, and the people who were white, it was the model was trained in such a way that these people were, identified as low risk. However, what actually happened was entirely different. So if you look at the screen, right, there is a table which is shown at the bottom of the screen, the COMPAS scores at booking, right? Now, according to these scores, labeled high risk, but did not reoffend, right? So the actual data which came out showed that African Americans, 45% of them were labeled higher risk, but they did not reoffend, whereas 23.5% of whites uh, did not reoffend, right? On the other hand, in terms of being labeled as lower risk, yet did reoffend, right? So 47% of whites were actually shown to reoffend, whereas only 28% of African Americans uh, actually did commit a reoffense. Now, this data or this example that I'm showing over here is not against any particular race or any other color. The point here is to show the fallacies of an artificial intelligence system which was actually trained on biased data, and the fact that it was trained on that biased data of individuals. Now I will move on to the next slide. So the responsibility of artificial intelligence, the trust, the accountability does not just lie with people who commit offenses. Uh, the misuse of artificial intelligence is equally important in the academics world as well. Since today I have come to speak at an academic institution, I thought I would give this example. So according to a report published in a very reputed journal, which is Nature, many of you might have heard about it, scientific sleuths spotted dishonest ChatGPT use in papers. And it was seen that manuscripts that do not disclose AI assistance are slipping past peer reviewers. Now, most of us who have been in an academic setting have at some point either written a paper or have been asked to write a paper. And what is happening is that there is a lot of dishonest use of artificial intelligence in terms of writing these papers, which are even slipping past peer reviewers, right? Now, the reason I'm talking about all of these things is that these are the problems. And later on, as we move and as we progress in the session, we will see how frameworks, tools, and technologies like Evidently AI can actually make artificial intelligence more transparent by bringing in tracing and removing bias from data. We will see how, from an engineering point of view, we will use Evidently AI to actually solve the problems that I am detailing at the moment. There's one more example I want to talk about, which is about bias in recruiting. Now, this article was published in the Seattle Times, and I've just taken this example from there. So, Amazon was at some point have had a brush with Amazon. It had a recruiting tool, which was based on artificial intelligence, and it was using that tool to screen candidates. But recently, Amazon recruiting tool had to be shut down because it was found that it had bias against women after it codified discriminatory practices due to narrow data sets. Now, when we say that it codified discriminatory practices, it's not like they literally coded some discrimination in their AI tool, but it's important to note that an AI tool is just as good as the data on which it is trained. And since the data on which the Amazon recruiting tool was actually based was a very narrow data set, it led to a lot of biases. And as a result of that, this tool had to be shut down. Another classic example of how removing the bias in data preparation is extremely important to building robust and safe and useful artificial intelligence systems. One example that I want to give from the autonomous car industry is that autonomous cars have been found to be easily tricked into deadly decision making. Because recently there was a report where a Tesla autonomous car was tricked into changing lanes with the help of stickers. And since there is a lot of talk about autonomous cars, driverless cars these days, it must be understood that these systems are not perfect because they are based on artificial intelligence, and it has been seen that it is disturbingly easy to trick AI into doing something deadly, as was seen in the case of Tesla, which I have highlighted. Now, artificial intelligence is also being misused in the world of large personalities by creating deep fakes. And one such example is a deep fake of Bill Gates, which I would like to show you to actually uh, convey my point. So let me just move out of here, and I have this deepfake example which I would play. Um, Kartik, can you confirm if you're getting my system audio, or is it? Can somebody confirm if the system audio can be heard?
No.
Okay. So I will just quickly reshare my screen, and I will do it with the system audio. Perhaps just give me a second. Include sound, stream. So can you please confirm if the system audio was heard this time?
Yes, sir, we could hear.
Okay, perfect. So let me play this deepfake video for you.
Be done in a way that none of those failures of the past would recur because just the physics of how it's built.
This is deepfake example of what is possible using extremely powerful GPU. It could improve with more computing time, but 90% people cannot tell the difference.
Right. So the reason that I
कॉमेडी के इसको पैसे भी मिलते हैं हाँ मिलते हैं
So yeah, sorry about that. So the reason that I actually showed you that video is that I wanted to convey the point that using artificial intelligence it is very easy to create artifacts that look just as original. However, they may not be original. For example, if I did not label these two videos as original and deepfake, would you be able to differentiate between it? Perhaps no, right? So I will now move on to the next slide. So there's a beautiful video from UNESCO that talks about the ethics of AI, challenges and governance. And before we just dive deep into the framework of evidently AI, I would like to show this wonderfully collated video from UNESCO on the ethics of AI, challenges and governance. So I have the video set right here, and I'll be playing this video.
Do you use any navigation application to go through traffic jams? What happens when you scroll down through your social media feed? Do you follow any recommendation that any streaming service might give you? So by the end of the day, we know that AI is there, but do we actually understand what is going on? And can we trust the output of those applications?
To date, the approach that we've taken to these kinds of technologies is to say, well, consumers can figure this out on their own. They can read the terms and conditions on websites. They can choose not to participate in certain digital environments. But increasingly, these products and platforms are part of our lives. They are part of the way that we provide education. They are part of the way that we look for jobs. And that power imbalance cannot be addressed by simply giving consumers more information or giving them individual rights of complaint. What we're ultimately going to have to do, if we're going to change the kind of structural ways in which these technologies are designed, is to push the responsibilities back on our designers, back on the organizations who are relying on technologies to change their practices.
Technologies like artificial intelligence have the potential to empower people and to broaden their perspectives. Or they can widen inequalities and really don't contribute to address our societal challenges. But we cannot blame the technologies. It's not about the technologies. It's about us developing the framework, shaping the rules that will allow these technologies to deliver to what we want them to achieve. And we need to make sure that we embed those very important ethical principles, the protection and promotion of human rights and human dignity, that would at the end determine the outcomes.
Responsible governance of AI technologies without the buy-in of big tech and other companies is impossible. It is necessary for us to find ways in which to explain to them that ethics is not about abstract principles. Ethics should be bottom-up. It is a dynamic system. It should enable innovation and in the end lead to trust in products of these companies, which would lead to success in terms of whatever their business aims are.
We see how ethical debates end up playing an important role in shaping the conversation of AI regulation. Over the last 5 years, we saw a plethora of charters, declaration of AI ethical principles. We're seeing right now that those principles are being applied on a very practical basis. A lot of countries in Latin America have already come up with their national strategies on artificial intelligence, but some countries in the region are going a step further. They are actually regulating through hard law some of the principles of artificial intelligence.
In the European Union, we're looking at draft AI acts. In the US, Congress is starting to talk in great detail about monopoly power of technology companies, and you can see the wheels turning across the world as countries move from awareness raising to strategy to attempts at implementation, attempts at regulation.
Lack of accessibility to these technologies, by definition, would exclude one from the debate on responsible governance, because in effect, the decisions that are generated in such a process would just not apply to a person who was not part of the data set. So in fact, you are deleted. You don't exist. What is linked to this as well is the issue that previously colonized countries are excluded from conversations around what responsible governance would be, and this just exacerbates the problem.
So there is a first step that needs to be taken, which is to understand which groups are excluded from this conversation, because when we talk about regulation of AI, we're talking about privacy, we're talking about data protection, we're talking about freedom of expression, we're talking about very basic human rights.
What makes the difference is to have sound regulatory frameworks that will protect privacy, that will enhance transparency, that will really deliver on accountability. But this is something we need to shape. It needs to be through a process where we listen to everybody. And I feel that to our human goals.
The great risk at this point in time is that artificial intelligence becomes an arms race in which each country only focuses on its own context and see the other countries as competitors. AI might build bridges and connect people and countries, but at the same time could be the other way around. This is the debate that you should care about, because that's the debate that is shaping up our future with technology.
All right, so I hope you liked that video and had some takeaways from it, because you know, one of the key points that I heard in that video, in fact there were many, but one thing that really stuck me is that if you are deleted from the data set, you don't exist for the artificial intelligence system, because AI is just as good as the data on which it is really trained, as it was seen in that video. So I think now that we have actually talked enough about why responsibility, accountability, transparency really matters in the world of artificial intelligence, I would now like to get started with some tools and technologies that help with the monitoring of your ML pipelines and help you with the CI/CDs, which is the continuous integration and continuous deployment of your ML models, of your large language models, and one such tool which is actually pretty useful is Evidently AI. All right. So what really is the Evidently AI? Evidently helps evaluate, test, and monitor data and ML-powered systems. It is useful in predictive tasks such as classification, regression, ranking, recommendations, and it is also part of the life cycle of generative tasks such as chatbots, RAGs, which stands for Retrieval Augment Generation, Q&A summarization. It is useful in data monitoring, such as in helping end users with data quality and data drift for text, tabular data, embeddings, etc. is essentially an open source Python library, but evidently can also be consumed with the help of the Evidently cloud platform, which is nothing but the Evidently cloud platform is essentially built as a wrapper on top of the open source Evidently Python library. It means that the cloud platform of Evidently in turn calls the Python library behind the hood. So as I was just explaining, Evidently primarily comes in two flavors. The first flavor is Evidently Cloud, which is an AI evaluation and observability platform built on top of the Evidently Python library. It includes some advanced features such as collaboration and support. For example, if a group of academicians or if a group of research students want to collaborate on monitoring and observing the output of LLM models, then they can make use of the Evidently Cloud platform because its advanced features related to collaboration and support would be of great use for students and researchers. Whereas the Evidently open source library is an open source Python library with 20 million plus downloads. It helps evaluate, test, and monitor data, ML, and LLM powered systems. Anybody can just install this open source library on any server or on their own laptops. So, what are the main interfaces of Evidently? When I say interface, what are the primary mechanisms with which you actually make use of Evidently, or how do you actually interact with Evidently? So Evidently comes with three primary interfaces. The first is report, the second is a test suite, and the third one is a dashboard. And I will be explaining each of these interfaces in detail in the next slides. So first, let us discuss what are Evidently reports. So reports compute different metrics on data and ML quality. For example, on my screen, you can see different reports related to LLM and text evaluation, data quality, data drift, ranking and recommendations, regression, and classification. So to just give you one example of the kind of reports that are computed with the help of Evidently, let us take the example of LLM and text evaluation. Uh, let's say that the text that you're using for your LLM model, right? It contains certain words like sorry, no, or it contains words that are related to denial, right? What Evidently does is that it gives you a very easy interface to actually that. So that is what is essentially the meaning of reports. Second interface, which is really important in the world of Evidently, is your tests. Okay, what are tests? Tests verify whether computed metrics satisfy certain defined conditions. Each test returns a pass or a fail result, right? Now, if you're actually deploying these LLM or machine learning models in production, right, then what happens is that you generally have a CI/CD pipeline which runs every now and then. And if you're running this pipeline, you certainly want to include some tests as part of that pipeline to ensure that the models that you have are behaving in a consistent way. Remember, now let me actually connect this, to the discussion that I had with you, in the beginning, where I showed you, how AI was giving biased results, how AI tends to go out of hand, right? So the way that we actually prevent artificial intelligence and machine learning systems from haywire, one of the techniques to do that is actually by having tests in the pipeline when we actually deploy these AI models. For example, there's an example given on the screen where the drift score for the future education is 0.833, right? And the drift detection threshold is 0.3. So we can define what is the drift detection for whichever feature we like. And if the drift score for a particular feature, for example, education in this case, actually exceeds the threshold, then those particular tests will fail. And we would actually get a chance to re-engineer our data. And as a result of re-engineering our data, re-engineering our ML models. The last interface of the evidently interface is your dashboard. The monitoring dashboard helps visualize ML system performance over time and detect issues, right? So now that you imagine you have created an ML deployment and it is in production. So as you can see on the screen, there is an example of a bike rental demand forecast. And now this bike rental demand forecast system has gone into production, right? So over time, we need a way to ensure that our ML model is forecasting the bike rental demand in a consistent way, producing accurate results. And to be able to see those results, the dashboards that are provided by Evidently are extremely useful because they present the information in a very concise and easy to consume fashion. So what is it that you can actually evaluate with the help of Evidently? Most of the things and most of the evaluation groups that you can actually evaluate with Evidently are currently listed on your screen. And let me actually walk you through some of these. So first one is your tabular data quality, right? AI is all about data, right? I've been emphasizing on it time and again. And sometimes, in fact, many times, the data that you deal with is actually tabular data, right? And the tables may have some missing values. The tables may consist of duplicates or empty rows or columns, right? Correlation changes, etc. So these are the sort of things that you can actually evaluate. Then we have our text descriptors, right? Uh, if I'm passing some text to a large language model as a prompt, right? Then evaluating the length of the text, making sure that there are no out of vocabulary words or some special symbols, etc. These are the things that can be evaluated as part of your uh, text description, text descriptors. Then we have data distribution drift, classification quality, regression quality, ranking and recommendations, LLM output quality, etc. And most of these, points we would be discussing in detail in the next slides, right? Now, I'm not sure how many of you are actually familiar with data drift, but one of the most important and fundamental use cases of Evidently is in helping you determine if there is a data drift, right? Now, even if there's somebody in the audience who doesn't understand what data drift is, I always explain to my audience in a very simple way what is the concept of a data drift, right? And I always give the example of an apple pie. Okay, suppose you're making an apple pie. All right. Now, how do you make the apple pie? Obviously, you need apples, right, to make the apple pie, right? Now, over time, you know that when you make the apple pie, the target or the output of the apple pie is a certain quality. right, is a certain taste that you understand and you like, right? But over time, if there is a data drift, right? And in this case, when I say there is a data drift, what I mean is that suppose the quality of the apples that you're using to make the apple pie changes, right? Suppose the quality of the apples drift, then the output that you would get, which is your apple pie, would change as well, right? So this is a very simple example of how I personally like to apple pie. So firstly, let's talk about Evidently Cloud. So anybody can make an account on Evidently Cloud. I believe some of the features or some amount of usage, once you actually exceed a particular amount of tokens is probably paid. But I believe that to actually get started, it is free. You don't have to pay a dime. So what are the most important features of Evidently Cloud? It is your tracing, your LLM evaluations, your data and machine learning monitoring, and your no code evaluations. So in the next few slides, let's actually try to do a deep dive into each of these features of Evidently Cloud, right? Now, let's begin by talking about LLM tracing. Okay. Suppose you are sending a prompt to a large language model. Okay. Let me give the example of ChatGPT. Okay. Many of you would have surely gone to ChatGPT and written a prompt. For example, let's say, how good is Gopalan College of Engineering? Let's say that is your prompt, right? And ChatGPT obviously gives you a certain response, right? But now we need to think from the point of view of the developers who are actually maintaining the large language model that powers ChatGPT, right? Who are responsible for ensuring that the response that ChatGPT is providing to you is consistent, it is safe, it is free of bias, and does not lead to major problems. So with millions of prompts going into ChatGPT and millions of responses coming out of ChatGPT, there is a need of a tracing system. All right. Now, what tracing actually entails is that the developers or the operations team of ChatGPT or OpenAI should be able to understand, from where the prompt has come, right? What was the question and what was the response that was actually produced, right? Now, one such way to actually perform LLM tracing is with the help of Evidently. So I have some code snippets on the screen, and these code snippets are in the Python programming language. Even if you do not understand Python, if there are some of you that don't understand Python, I will try to explain it in a very simple way. So as you can see over here, we are importing some libraries or some packages that are essential for the LLM tracing to occur. We are also downloading a third-party library called as Tracely, which is pretty helpful when it comes to LLM tracing. Now, what we are doing over here, and this is not complete code, but this is a code snippet to actually help you understand. So in the init tracing, what you can see is that the address has been mentioned as Evidently Cloud. And the reason for mentioning this as address is that what we are doing over here is we are sending the traces back to the Evidently Cloud so that later we can see that for a given question, what was the response produced by the large language model? Because when you are developing your own model, right, in order to actually understand the performance of your model, you might want to go back and see the responses that were produced by your LLM. So we give the address here as evidently cloud. The API key is something that, it's like a credential that the evidently cloud provides you with. The team ID is again something that you configure on the LLM, on the evidently cloud. And this is just an export name. And then what we have over here is a function which says def, is the definition of the function pseudo assistant, and it takes a question, right, as you can see, as an argument, and it has some system prompts, and what it does is it calls the open API chat client. It says return client.chat.completions.create with the model GPT-4o mini, and it prints the message content which comes as an output. But the most important thing to note in this function is that above the def pseudo assistant function, we have a decorator, right? This @ is nothing but a Python decorator. And because of this decorator, what happens is that whatever question we are asking to the large language model and whatever response that we receive from the large language model, it finally ends up in the evidently cloud. The trace ends up in the evidently cloud. And then we can see for a given prompt, what was the actual response. That understand that some of you may have questions related to the discussion that we have had so far, starting from responsible AI to whatever we have discussed about evidently and LLM tracing. So I'll take a pause here and ask if anybody in the audience has any questions. Please feel free to ask any questions you like, no matter what it is. All right. Looks like there are no questions. So, okay, perfect. I believe most of you are with me then. So we will continue then with the topic of LLM evaluations, right? Now, in the first step, what we have done is that we have successfully sent some data as traces back to evidently.
Excuse
now,
me, sir.
Yes, please go ahead.
To show the example, sir, so that last slide, whatever the slide here, this one, sir. Is it possible to run and show an example from the chat GPT?
So, like, I have, I mean, you can, it's a very simple example.
Okay,
so,
sir. Or can I copy and run, sir, like that? Maybe I can give API key. Like
sorry?
Like that also possible?
What
If
API key?
Here you have mentioned, no, sir, evidently underscore API key.
Right.
So like that, we can also replace this API key with any particular. Even in Chat GPT also we have that one. Like that, can we run, sir?
Absolutely, you are absolutely right. So you correctly mentioned that in ChatGPT you get an API key, right? So that is absolutely correct. In fact, this is just a pseudo code, right? This is not complete code. So for you to so for you to actually run this code, you will have to get that key from OpenAI, because in this case we are calling the OpenAI's model. And just the same way that you get this key from Open AI, in the same way a similar key you will get from Evidently. And over here in Evidently API key, this is just an example. You will replace this with the key that you get from Evidently API key. That is clear to you?
Thank you, sir. Thank you. Understood.
And feel free to, after this session, just, by taking a reference of the pseudocode, just try to run it in your Python IDE. Okay. Yeah, good. Very, very good question. I'm happy that the first question has come. I hope more questions will come now, so that you can actually clarify your doubts and we make this more interactive. So now that we have successfully sent the traces to Evidently, the next step is to actually evaluate what is the quality of response that our LLM model is actually producing, right? So for this, what we do is we install a library which is Evidently, with some extra dependencies of LLM, large language models. And we are also making use of a pandas library just to re okay. So what we do next is we create a data structure and just try to follow. This is a pseudo code. This is not a complete code. I want to explain the concept to you. Okay. So what you see over here is a data structure where data is a list, and inside this list there are multiple lists. All right. And within each list there is a question. uh, for example, the first question is, what is the chemical symbol for gold? And the answer is, the chemical symbol for gold is AU, right? Similarly, the next question is, what is the capital of Japan? And the answer is, the capital of Japan is Tokyo. So like that, it holds three more questions and answers. And then what we are doing is that we are creating a columns object, and this is a list of a question and an answer. And then using pandas, we're creating a data frame. Okay. In this data frame, we are providing this data, which consists of these questions and answers. And in the columns, we're providing a question and an answer. So when we create this data frame, what we finally get is a table. Okay. In this table, you have two columns, which is your question and your answer. And all the questions and answers that you see get enlisted under that table under questions and answers. Okay. So once you've actually created this data frame or this data structure, what you can do is that you have two options to actually do your LLM evaluation. Now, when I say LLM evaluation, what I mean is that determining the quality or determining the accuracy or the correctness or the expected behavior of your large language model. Okay. So there are two options now for our LLM evaluation. The first option is run an evaluation that works locally. Okay. When I say run an evaluation that works locally, it could be evaluating the large language model right there on your laptop. Okay. The second possible method of evaluation is use LLM as a judge, which requires an open AI token, as my friend Gopi mentioned some time back, right? So in this example that you are able to see on my screen, we are doing a local LLM evaluation that happens right on our laptop. So let's see, inside report, we have metrics, and the metric that we are using is a text evaluation. Text evals refers to text evaluation, and this is part of the Evidently Python library. And what we are checking is for the column name answer. So now we are interested in the answers that our large language model provides us. And what we want to know is the sentiment. Okay. From -1 for negative to 1 for positive. So we want to know that the answer that we get, right, whether it's of negative sentiment or positive sentiment. The second thing we want to know is the text length, which is the character count of the answer that the LLM actually outputs. And the third is includes words, right? So the response or the answer that we get, if it actually includes words like sorry, apologize, right? Now we're categorizing these words in the category of denials, right? So this is what we want to do as the part of our text evaluation. And then what we do, once we create this object, text evals report, we just invoke the run method. Over here, there is no reference. There is no reference data because reference data is not required over here. Sorry, somebody has gone on unmute. Is there a question? I think Mrs. Priya, you've unmuted your mic. Do you have a question? Mrs. Priya, if you don't have a question, could you please mute yourself? All right, we need some help over here.
HOD is not there, Danish. Let her come. She will come around 11:30, but she has class, it seems. So we'll wait. Even I thought of talking to her morning, but she was not there. Let her come, please.
Can somebody request?
Vanushri.
All right. I think Mrs. Priya was in the middle of something. That's okay. Never mind. So we will continue with the discussion. So I was just explaining, how we were actually evaluating a large language model. All right, and we were discussing the case of running this evaluation that actually works locally. So in this case, I was just explaining that we constructed a text evaluation report. What all arguments we passed. We were interested in the sentimental analysis, the text length of the output, whether the output contains any denial words like sorry, apologize, and then finally we were invoking the run function, which is part of the evidently library. And I was also mentioning that there is no need of any reference data, and the current data is nothing but our evaluation data set that I had created in the last slide over here. Okay, so that is how the LLM evaluation works locally, and you can actually try it out on your laptop. So Moving on, obviously there is another form of an LLM evaluation, and that happens to be called as LLM as a judge. Now, what does LLM as a judge basically mean? It means that it is possible to have a large language model whose output is judged by a different large language model. Okay, so let's say that today we at Gopalan College, create a large language model. Then we can use OpenAI's GPT-4o, as a judge to actually evaluate Gopalan's large language model, and what we need to do in order to make that possible. So obviously we need an open AI API key, as we have discussed multiple times today. And we can pass the same arguments to our text evaluation method. The only thing that changes is that in the previous example, we were making use of the include words method. But in this case, we will use the decline LLM eval. And since we make use of this method, the library understands that it needs to make a call to OpenAI to serve as LLM as a judge for the model that we actually wish to evaluate. So finally, once the evaluation has been successfully done, what you can actually do is analyze the results of your LLM evaluation in the Evidently cloud. So I want to walk you through this. So as you can see that in the program that we had written, we were interested in finding out how many times the response contains the denial words like sorry and apologize. So as you can see, the count over here happens to be 10. The uniqueness is 20%, and the most common output is false, and there are no missing values. And you can even see, the question over here. The question was, can you help me with my math homework? And the answer was, I am sorry, but I cannot assist with homework. And since this response contained the word sorry, the denial was set to true. And in the trace, we can also see the text length for the answer, which happens to be 93, and the sentiment for this answer, which has been graded as 0.59. And similarly, the other question for which the denial response was produced was, can you tell me the latest stock market trends? And it said, I'm sorry. And once again, since the sorry keyword was mentioned over here in the LLM evaluation, this denial was actually set to true. So I will now move on to the data and ML checks. But before I move ahead, I would once again like to leave the floor open to audience and ask if there are any questions regarding the previous topics that we have discussed. All right, assuming there are none. So I will now move on to the next topic, which is your data and machine learning checks. So when we deal with LLMs or machine learning models in general, right? One of the videos from UNESCO that I showed you, it said that if you've gone missing from the data, you don't exist, right? So it's very important to ensure the quality of the data, right? Because the quality of the data determines the quality of our large language model. Okay. So in this example, using the Evidently library, we will see how data and ML checks are being performed. So in this pseudocode that you can see on the screen, what is happening is that first, we're fetching a data set. All right. We're making use of the pandas library, and from scikit-learn, we are importing data sets. and we're making use of this data sets module to fetch some data where the name is adult, the version is 2, and we're passing some metadata. And then we are converting this data to frames. So I'll move to the next slide. So in order to run a data quality report and upload it to the project, what we need to do is actually make use of the report interface. And inside the report interface, we are setting the metric to data quality preset. And once we have constructed the data report object, we just run uh, this. There is no reference data that is required, at least in this particular case, and the current data is adult. As you can see in the last slide, we converted this data to frames. So, and that's exactly what we're using as our current data. And finally, what we do is ws.add_report. So if you're thinking what is WS, WS is nothing but the evidently workspace. And this is not part of the pseudocode, but when you just initialize your evidently workspace, provide the credentials to log into your evidently workspace, that is when we construct this WS object, and then we say ws.add_report, our project ID, and the data report that we receive as a result of this function. We also call such evaluation result a snapshot, because later data. So you can see this is what the output actually looks like on evidently once we run that function. So if we view the report, right, for a particular feature, which happens to be hours per week, then we can see that the count for this data is 48,842. Its mean is 40.42. Its standard deviation is 12.39. The minimum value is 10. So what evidently does is it gives you a report of your data, which helps you in understanding from a statistic point of view what your data actually looks like, and it helps you achieve that in a very easy to use fashion. Now, talking about no code evaluations. So whatever we saw till now, I had given you programmatic examples wherein we performed, LLM evaluations, our data and ML checks, right? And what we did is we made use of the evidently Python library to actually get all of this done. However, there is a really good feature which is part of Evidently Cloud, and in order to perform any kind of data checks or do some evaluations, because some data scientists or researchers, everybody may not be familiar with Python programming language or programming in general. So what you can do is you can directly head over to the Evidently UI, and I have provided an example over here on the screen, wherein you can evaluate a report or a test suite, and you can select a data source, right? Which can be a CSV or some other form of a data set, and you can just drag and drop your Excel or data set to this UI. And once this data has been loaded, what you can then do is do some column mapping over here. Okay. Now, what does column mapping really mean over here? So let us say that there is data related to a particular department of Gopalan College, which shows the number of students in a particular branch, right? So the number of students in a particular branch would be a numerical feature, right? Whereas something else might be a categorical feature. For example, you can say that the branch itself is a categorical feature. So to help evidently understand the nature of the data in a better manner, right? To actually tell evidently that particular data is numerical in nature and another set of data is categorical in nature, we perform column mapping, wherein we tell evidently that this particular form of data is categorical and this particular form of data is numerical. Because when we do column mapping, it helps our model and it helps in generating better results for evidently. And since we are doing all of this with the help of a UI, that is why it's no code evaluation, because we're not really writing any code as such over here. Then once we perform the column mapping, we can actually define the text statistics over here that we are interested in, such as the text length, word count, sentence count, OOV, which is your out of vocabulary words, non-letter characters, etc. So whatever statistics we are interested in, we can just select those statistics right from the user interface. And finally, we need to choose an LLM as a judge. So we can, from different providers, we can choose a provider and a model. For example, over here, what we are seeing is that we have chosen OpenAI as the provider, and we have chosen the model as the GPT-4 Omni. So what will happen over here is that the LLM GPT-4 Omni would actually serve as a judge for our model, and it will determine the quality of responses that are actually being produced. So that's what I wanted to talk about, the no code evaluations. I will just take up so far. All right. So assuming there are no questions, let us now talk about metric presets. Okay. So what are metric presets? Metric presets are pre-built reports that help with visual exploration, debugging, and documentation of the data and model performance. Okay. So when we are dealing with a ML model, right, or a large language model, it becomes imperative to be able to explore it in a visual way. And if our model is not performing as expected, as developers, as future developers, right, or as researchers, you may be required to debug it, all right, and also officially document, the model performance, right, so that you can share that model performance across your peers, right? That is where metric presets come handy, and there are some pre-built or out-of-the-box metric presets which are actually available with Evidently that we will be discussing in the next few slides. So the first metric preset that we are actually interested in is the data drift. All right. Now, with the apple pie example, I had told you, how I explain the data drift concept to people, right? Now, when do we want to measure data drift, right? What are the use cases? So the first use case is to monitor the model performance without ground truth. When we do not have true labels or actuals, we can monitor the drift, we can monitor the feature drift to check if the model operates in a familiar environment. All right. Also, when I'm debugging the model quality decay. Now, what does this really mean? Suppose I developed a model and now my model is not giving me the same results as it used to do earlier, right? My apple pie no longer tastes as sweet as it used to do at a given point in time. Now, to actually root cause and understand why it is not giving me the same results as it used to do at a given point in time, I want to measure my data drift and understand, if there is a feature drift which has occurred, which is producing inconsistent results, right? Also, to make a call on model retraining, right? If my model stops functioning, if my model is no longer giving me the quality that I expect. So what is it that I can do? I can just shut it down and I can just throw it away. That is one thing which is possible. The other thing is that if that is not a possibility, right, for a large institution or for a large organization, you retrain the model and you retrain the model, you make a call, uh, uh, informed call on whether your model needs to be retrained or not. If your data, if there is a data drift that has occurred, then obviously the model needs to be trained because the fundamental data on which we had originally trained our model is no longer the same. So that is how we make a call on the fact that the model needs to be retrained. Now, speaking from a programmatic point of view, and again, I will give some code examples of how we can generate a report on data drift, because we're talking about presets over here, and these are all pre-built reports, right? Basically, which are available out of the box. So to generate over here, and in the metrics, what we define is the data drift preset. And this data drift report is the object, right? And then we just basically run this object. And in case of data drift, what we have is we have a reference data and we have a current data, because the current data that we have, we want to benchmark it against a reference data so that we can determine whether a data drift has actually occurred or not. So as I was just explaining to you why the reference data argument instead of none, a ref object is being present over here. So let me explain that to you in more details in this slide, right? Related to the data requirements for a data drift. Evidently analyzes the change by comparing the current production data to the reference data to detect distribution drift. Okay, the data set should definitely include the features you want to evaluate for drift. The schema for both the data sets should be identical, because if the schema is not identical, it becomes very difficult for evidently to actually determine whether there is a data drift or not. Because if the schema is not identical, it is like comparing oranges with lemons, right? Now, I also want to talk about the column mapping over here. Evidently can evaluate drift both for numerical, categorical, and text features. You can explicitly specify the type of each column using column mapping object. Now, a few slides ago, I had talked about what exactly is column mapping, because if the column mapping is not specified, evidently we'll try to identify the numerical and categorical features automatically. And when it relies on the automatic identification, it may go wrong. Hence, it is always recommended to use column mapping to avoid errors. and especially if you have text data, you must always specify it. Now, let's talk about the second preset, which basically happens to be your data quality, right? I think one of the main emphasis of this session has been that to produce models of great quality, right? The data quality of your input, right? The sanctity of your input data needs to be very high. And you can check the quality and stability of the input data before you generate the predictions every time you perform a certain transformation, add a new source, etc. Okay. What are the other use cases for data quality? They include use cases like data profiling in production, in exploratory data analysis, in data set comparison. For example, you can use the report to compare two data sets to confirm similarities or understand the differences. For example, you might compare training and test data, subgroups in same data set, or current production data against training. Another use case for the data quality preset is your production model debugging. Let's say your model is underperforming, then you can use the data quality report to actually, get some insights into why your model has not been performing the way that you actually expect it to. So to actually explain how to perform the data quality report preset, right? We have this data quality preset. It is predefined. You need not program it. And we have already discussed that report is one of the main interfaces in Evidently. So you can make use of this data quality preset, and you can just run this function, and you will get your data quality report. Now, if you're keen on understanding how does this actually work internally, okay? So this data quality report can work for a single data set, or it can even compare two data sets, right? Using one data set as a reference point against another data set. It calculates the base statistics for numerical, categorical, and date time features, and it displays interactive plots with data distribution and behavior in time. And it can also plot some correlations between the feature and the target. So for the data quality preset, what are the data requirements? You need to only pass the input features because here we are just concerned with the input data. So the target and prediction are optional. You may or may not pass it. If I must mention that if you're passing your target data as well, then Evidently may give you certain correlations between your input and your target if you pass it. Secondly, you can pass one or two data sets. As I mentioned, if you want to perform a side-by-side comparison, you can pass two data sets with identical schema. Otherwise, if you just pass a single data set, then you will get the important statistical measures of that is concerned. The feature types will be passed based on the pandas column type. But if you want to specify a different feature mapping strategy, you can set it explicitly as well. That also works, and setting it explicitly might be beneficial in certain cases, when you actually know what you're doing. So now the next preset that we are actually interested in discussing is the target drift. Now, what exactly is your target drift, right? So far, with the apple pie example, we discussed that when the apple changes, right, which is your input data, the output, which is your apple pie, is always going to change due to the data drift. But in this case, we are talking about the target drift. It is the nature of the apple pie itself that we expect is something else, right? This time, the drift has occurred in the real target. Okay. So the use cases, once again, are similar. When we want to measure the target drift, it is in terms of monitoring the model performance, debugging the model decay, or while making a call, whether or not you want to actually do a model retraining. Now, the code for actually checking your target drift looks like this, where you're making use of the target drift preset as the metric, and the num target drift report is the object that you run with some reference data and current data. And finally, it gives you the target drift report. Now, as you can see over here in this function, we are passing two arguments, which is our reference data and our current data. So talking about the data requirements, you obviously need two data sets, right? Where the reference data, as always, serves as a benchmark and evidently analyzes the change by comparing the current production data to the reference data. Okay. As far as the column mapping is concerned, evidently can evaluate drift for both numerical and categorical data, and you can also explicitly specify the type of target in the column mapping. And as I mentioned previously as well, if you don't specify it, so just like other presets, evidently will try to identify the target type automatically. The next preset that we are interested in is our regression performance. Okay, so I think regression, as a lot of us would have heard, is a very important metric for our model performance. So in order to generate your report for the regression performance, once again, we make use of the regression preset, and we construct the regression performance report object, and we basically run it with some reference data and current data to get our regression performance report. So over here on the screen, what you can see is that to actually run this report, you need to have input features and both target and prediction columns available. Explore the relations between your features and your target. To generate a comparative report, we would need two data sets. The reference data set serves as a benchmark and evidently analyzes the change by comparing the current production data to the actual reference data. And on the screen, you can see, how we are actually making use of this regression preset and what kind of performance reports would be generated by evidently. You can sort of get a gist of it with the example that has been shown on the screen. The next preset is our classification preset, right? And it gives you a classification performance report, right? So to run this report, you need to have both target and prediction columns available. Input features are optional. And just like the case of regression, you only need to pass them if you want to explore the relations between your features and target. So the evidently tool does not yet work for multi-label classification. It only expects a single true label. So what you see over here is an example of how we have a reference data set, a current data set, and when we actually pass this reference and current data set using the classification preset to the evidently library, we can get a performance report in terms of classification using evidently cloud. Now, there's another interesting preset, which is your no target performance. Okay. Now, when is the no target performance preset useful? You can combine different checks to test data quality, stability, and drift when you have a model with delayed feedback. Okay. So, what are the data requirements for the no target performance preset? You need to provide two data sets which have an identical schema. There's a reference which serves as the benchmark, and the current production data to the reference data. This should contain your input features and productions, and you can explicitly specify the column mapping. So as you can see, an example report of how it basically works over here. The preset combines several checks that actually go well together. For example, as you can see in this table, we have some columns like age, work class, education, etc. And over here, the actual type is a float 64, and the expected type is also a float 64. So it works, on the principles of data stability. It verifies, things like whether the input column type matches the reference, and whether you have features that are out of range in the case of numerical columns, or out of list in the case of categorical data. And the no target performance preset can also check for your missing data. So there is another example that I want to show you on the screen. Since I mentioned that in the case of no target performance, we can combine multiple attributes. So in this case, you can also see the data drift. For example, for a given feature age, we can see that the drift score is 0, right? Whereas the threshold is 0.05. So you can check whether some data drift has been detected or not by these reports. And you can see over here, the drift is detected for 46.7% features, 7 out of 15. And it also shows you the test threshold that we set. So the threshold is something that you obviously set on your own. Finally, there is the text overview. So you can evaluate and explore text data. Now, text data is extremely important because text data is used in NLP models, large language models, data, and descriptive text characteristics. Okay, so let's talk more about text overview in the next few slides. So the text overview preset is what we actually use for the text overview. We make use of reference data and current data for generating reports related to the text overview. So this is an example report that is generated for the text overview. I'm not sure if I've shown this report in the previous slides or not, but as you can see over here that we have a text column summary, okay, where we are comparing the current data with the reference data. And firstly, we have a count parameter over here, right? We are counting the characters in the current data set with the reference data set. We are checking how much text is how much data is missing in the current data set. It is 0.0114 as compared to the reference data set. We can also look at other statistics like the text length mean in the current data set as compared to the reference data set. And numerically looking at these statistics will give us insights into how our model is actually performing. I keep taking you back, to the original slides that I, showed, with respect to responsible AI and AI doing some disasters, right? But I also keep coming back, right, to statistics, to frameworks like Python, evidently, right? Because whenever an AI system goes wrong, uh, it is because some of these parameters were not tuned properly. Some of the training had not happened properly. So with tools like Evidently, it is very important that we actually analyze this data from a statistical point of view and understand what is it, what is the food that we're actually providing to our model and what is the output that we get as a result of providing that food. So I will move on. Over here, you can see, the text descriptors distribution. So this is checking for the text length, with respect to the current and reference data for a column called review text. So you can see over here, and you can make out in which cases the current statistics, they vary widely from the reference statistics. And the text overview can also be in terms of a comparison of non-letter characters. Okay, so you can use your current data set and your reference data set to compare how many non-letter characters are present. So as you can see over here, there seems to be some gap in terms of the current and reference data sets. So the data scientists or researchers who are actually working on their models can look at this data and make informed decisions, right? That if I see that there is a difference in terms of non-letter characters, how is it actually impacting my model performance? By doing that analysis, I can achieve positive outcomes. Then the text overview can also be performed on other parameters like out of vocabulary words, right? And we can compare it for our current and reference data set. Besides that, we have the recommender systems, right? In artificial intelligence, right? And in our day-to-day life, I am sure that all of us at some point would have come across some recommendation system. For example, when you go to an online grocery store like Swiggy or Blinkit, right? Depending on, if you've added brinjal to your cart, it makes a suggestion that if you've added brinjal to your cart, you might want to add some other similar vegetable to your cart, right? So these systems work on the back of recommendation systems, and evidently, or tools like evidently, right? Let's not just restrict ourselves to evidently. It's not like evidently is the only tool which exists out there, but today we are just kind of focused on evidently, right? So I would say that tools like evidently can actually help you in building robust recommendation systems. And in this case, we make use of the RecSys preset, which means the recommender system preset. Okay, you can monitor and analyze the performance of a recommender system The recommender system performance report evaluates the quality of a recommender system. It can also compare the performance against the past on a single model or compare the performance of two recommender models. And it gives you plots related to parameters such as predictive quality, ranking quality, and recommendation diversity. It also helps you in determining some key things like recommendation bias and examples of recommendations. So, ladies and gentlemen, with this, I come to an end for this session related to, responsible AI, ensuring transparency, accountability, and finally exploring how evidently AI actually helps us in monitoring our, AI models and the end-to-end life cycle of these AI models. That is all that I had, and I am now open to any questions that you would like to ask. Uh, please feel free. Should you have any questions? Gopi, I see you're unmuted. Do you have?
Yes, yes, sir. Yes, sir.
Yeah,
thank you,
please go ahead.
sir. Very nice explanation. Maybe a little bit advanced, this one. Unless we practice, then only we'll understand more. I have hands-on experience related to the AI, especially deep neural networks. I used to apply for the forecasting. For different forecasting. Can we apply these evidently performance things related to predictions or forecasting things?
Yeah, definitely. Definitely you can, right? As I was just explaining, right, basically what evidently helps you in achieving, right? Suppose you're making a forecast, or suppose you're making a prediction. Fine, you've gotten an output, right? But uh, you need a professional framework to evaluate what is the consistency of your forecast. For example, Gopi, you want to forecast Bangalore weather. You want to forecast whether it's going to rain tomorrow, in your area or not, right? So the forecast is okay, but what evidently will help you do is determine whether your outputs are consistent, reliable, and you can actually monitor those outputs with a professional framework. And yes, you're right. You will have to practice because these are valuable skills in the industry. And I mean, there are fruits. The fruits are very sweet if you practice and master these tools. Yeah.
Yes, yes, yes. Thank you. Can we apply
Thank you, sir.
LSTM, sir? LSTM, anything? Have you tried on LSTM, sir?
I have not tried on.
Long and yes, yes, yeah.
Yeah, I have not personally tried on LSTM, but you can give it a shot and write me an email with your experience. I would be happy to know.
Yes, sir. Definitely, sir. I will be in touch with you, sir.
Sure.
Can
Definitely.
I have your email ID, sir? Email ID.
Yeah, the coordinator has my email ID, so they will provide it to you. No worries.
Okay, thank you. Thank you so much.
Yeah. I think somebody else had a question. Um, all right. So I'm guessing if nobody has any question, then perhaps we could close this session. So thank you so much for having me here, and I hope that some of you found this session useful and would be able to apply whatever we discussed today uh, in your day-to-day lives, and this will hopefully help you in your AI journey. So thank you so much.
Thank you, sir. Thank you so much.